Okay, let's look at completing the square. There are two reasons. There could be another one more which not so critical. Two reasons why the need to do completing the square. Okay. One of the major reason is to find the xy coordinates of a quadratic function. Okay, for example, if you have convert a function, okay, into, let's say, x plus a square minus b. Okay, now if you manage to convert the function into this manner, then your x coordinate or your turning point is x plus a equal to 0, x become minus a. So this is the x coordinate of your turning point. Now, then the y coordinate will be equal to this, inclusive of the sign. Is plus b, then y is equal to b. Is minus b, then y equal to minus b. Okay, so in this case, if you want to sketch the graph, the quadratic function, then x is minus a, so it's minus a here. Y is minus b, let's say it's minus b here. Therefore, remember this x squared is positive, so it's a minimum curve. Okay, now beside that, what else do you know of? Now, now the other things that we can obtain from here is, what is your y-intercept? Y-intercept is when x equals to 0, right? So the y-intercept is when x equal to 0. So this function become, if x equal to 0, so it's a square minus b square. Minus b. So this value here will give you the y-intercept. Okay. So in this case, it becomes like that. And this is your a square minus b. Okay, when x equal to 0, the y value is your y-intercept. Now, second reason, this is the first reason. The second reason why you use completing the square is, let's say you were given y equal to x squared plus x minus 3. Okay. If you are asked to find the inverse function, okay, that means you must make x a subject, and then whatever on this side is y term or some constant. But obviously, if you do the conventional way, okay, the conventional way of making x a subject, you will not able to do it. Okay, you're not able to make x and then followed by other term like 3 or 7 or any other term. There shouldn't be x over here. But if you do it the conventional way, you cannot end up in this manner. So that is how completing the square will be able to come in and make x the subject. Okay, now let's go back to this one. So fx, let's say let fx be y equal to x plus a square minus b. Okay, now so I can move the b here, y plus b, and then I square root it equal x plus a. Okay, now then I move the a over here, so it's actually y plus b minus a. Now do you see that? Now x is a subject, and on the other side of the equal sign you will not find any x term, so you have actually found the inverse function. From here this become a inverse function. Okay, you actually become the inverse function. The question is, you got a plus minus here because it's a square root. Okay, now remember, if it's a quadratic function, for it to have an inverse function, the function must be a one-to-one function. Okay, one-to-one function. Okay, what do you mean one-to-one? That means if you draw a horizontal line, you should only intersect with one point of the graph. But then for quadratic function, if you draw a horizontal line, you intersect with 2 points. So it failed the test. That means you cannot have an inverse function for a quadratic function. However, if you determine you make a change in the domain, for example this one, if I say that x can only be more than minus a, x has to be more than minus a. In other words, the quadratic function actually only like that. Okay, now let's carry out the test. If you have stated this in the question itself, so if you draw a horizontal line, any horizontal, there's only one intersecting point. I mean, he meet the requirement for a one-to-one function. So any quadratic function, if you want to have an inverse function, you must specify the domain in such a way that the quadratic function is end up a certain part of the quadratic function. Okay, when you specify the domain, and then if there only is a certain part of the quadratic function, then if you draw a horizontal line, then it's only intersect one point. Okay, so now come back to this. How do you decide whether to pick the positive or the negative? Okay, that you have to go back to the question and look at the domain that is specified. Okay, you go back and look at the x. What is the domain of the x? From here, you're able to pick the correct one, either the positive or negative one. Okay, so after whatever you pick must meet the requirement here, the x. Okay, then if you pick, then you have this function, and this become the inverse function for the quadratic function, but under the domain specified. Okay, you got it? So the second purpose of completing the square is to find is to establish an inverse function. Okay, you establish an inverse function. From there, you are able to determine the inverse function. But bear in mind, to do that, you have to specify the domain in such a way that if you specify that part of the graph, make sure that when you draw a horizontal line, it will not intersect 2 points. Okay, so that is the second purpose of completing the square. Okay, now let's go and look at wait, I missed out something. Okay, y equal to minus b. Okay, the y equal to minus b is the coordinate of the turning point, can be maximum and minimum, but then it carry a bigger meaning than that. It means the y function, the function value can go as low as minus b. That's it. Below minus b means less than minus b, the y, the curve doesn't exist. Okay, because by the time it reach this y equal to minus b, is already at the turning point. After that, it will go up again. So the significance of this y equal to minus b tell you the minimum value of the function. Okay, the y actually represent the function. That tell you this y equal to minus b, tell you what is the minimum value of the function. In this case, the mean value of the function is minus b. Okay, so that's the significant part of completing the square. Now, next, let's look at how do you do completing the square. Okay, now let's take a function y x squared minus 3x plus 4. Remember, to do the completing the square, you must create a term, x squared term, and a x term. The constant here, don't bother, just keep it one side, far away. Okay, you must create a term where you have a coefficient of 1 for the x squared. Okay, a coefficient of 1 for the x squared, and then this one will follow the x term. You must create this condition. Okay, so after that only you can continue to the next function, the next step. Now what you have to do is the x, then this sign here must follow minus, then the coefficient of x term must be 3/2, and then holding bracket. Now then you must minus this whole thing again. Okay, then you square it. Okay, now so the plus 4 is here, still plus 4. Now so let me rewrite it. So this is x minus 3/2 square minus 9/4 plus 4. Okay, now so x minus 3/2 is minus 2 1/4 plus 4, and that will give you x minus 3/2, sorry, let's be square, so become plus 1 3/4. Okay, therefore since this is positive x squared, so this is a minimum curve. So the turning point equal to x minus 3/2 equals to 0. So we move the x, the 3/2, so x actually become 1.5. Y value is 1 3/4. Okay, so that is the turning point for minimum curve. Now to find the x, the y-intercept is very simple. You just put x equal to 0, you get y equal to 4. Okay, now if you want to sketch this, so the point is here. This is 1.5 1/3/4. Then it's a curve. Remember, when you put x equal to 0, y equal to 4. So here is 4. Okay, so that's it. Now, what happens if you have a minus x squared? What will you do? Y equal to minus x squared minus 3x plus 4. Now, remember, I say that you must generate a positive 1x squared minus whatever x term. Okay, now I got a negative 1. So I must reorganize it in such a way that I have x squared plus 3x. The 4 keep it one side. Okay, now I have generate positive 1x squared plus 3x. If you multiply the minus inside here, I get back this. Okay, now I'm ready to do the completing the square. Now I got 1x squared, a positive 1x squared plus x term. So this become x plus this, plus follow the plus here. So it's 3 over 2 square. Bear in mind this time you got a negative, so you have to put another set of bracket, minus 3 over 2 square bracket. Okay, remember this negatives apply on these two terms, so you have to put this square bracket so that the negative is outside. So this, later when you multiply this negative, you're going to multiply this negative with this, at the same time you're going to multiply this negative with this. Okay, plus 4. Now, so you minus, you simplify what is inside. Now you're going to multiply the x, the negative inside, so it will become x plus 3 over 2 square, and then minus time will become plus 9 over 4 plus 4. So minus x plus 3 over 2 square plus 6 and 1/4. Okay, now since it's negative, it become a maximum curve. Now so same thing. So this is the x coordinate will be x plus 3 equal to 0, so x becomes minus 3 over 2, and then your y coordinate of the maximum point is 6 and 1/4. Okay, now do you notice that this negative doesn't play any role in the coordinates of the turning point? Okay, it only indicate whether it's a maximum or minimum curve. Okay, now so x minus 3 over 2, y is 6 and 1/4. So the point is here. So since this is a minus in maximum curve, so it will go this way. Now if you put x equal to 0, you get y equal to 4, which is the x-intercept. So let's say there's 4 here. So it means to say the curve actually go up here, pass through y equal to 4, the y-intercept will come down. So the coordinate at this point would be minus 3 over 2 and 6 and 1/4. Okay, so that is how you do computing the square. Now what happens if you have a coefficient of x squared, let's say 2, 3, then how are you going to do it? Okay, now let's come back to the negative one. You see, negative 1, how I handle it? You see, I have to remove the negative, so that I end up 1x squared plus 3x. Okay, the important thing, before you do any completing the square, you must have a positive 1x squared plus 3x. Okay, so that's why I remove the negative. Okay, now if you have a coefficient of x squared which is not 1, then you also have to remove it. Okay, now I'm going to do some example, so I'm going to erase this first. Now okay, 3x squared plus 4. Okay, now we're going to do y equal to 2x squared minus 3x plus 4. Okay, now the first thing I have to do is I must create a 1x square and an x term, okay, before I start completing the square. So what I'm going to do is I'm going to take out the 2. Okay, bear in mind, if you put a 2 in front of this bracket, when you multiply back, you must, for the x term, you must end up with minus 3x. So how do you end up minus 3x if you take the 2 multiply back to the coefficient of x? Then you put 3 over 2. So if you multiply the 2 back here, you still get a minus 3x. You have not changed the function at all. Okay? Now, so you have already rearrange and create the condition for starting the process of completing the square. You got a 1 in front of the x square. Okay, now so from here the 2 will remain outside, okay, and you only put in later part of the step. There's 2 brackets. Okay, the first bracket is the x. Remember this minus, you follow the 3 over 2, you divide by 2 again, the normal step to completing the square. So it's 3 over 4, and then you square it, then minus. Remember this minus here, this sign here is always negative. Okay, 3 over 4 square, then you have the square bracket, then you got plus 4. Okay, now the next step is you simplify whatever you can here. In this case is already you cannot simplify further. Now I'm going to multiply the 2 back, so I got 2x minus 3 over 4 square minus 2 times 9 over 16. Okay, square of 3 over 4 is 9 over 16 plus 4. Okay, now so you got a 2, you got x minus 3 over 2, 3 over 4, sorry, square. Now here I'm going to simplify, got an 8. So it's actually minus 1 over 8 plus 4. Okay, simplify it further to x minus 3 over 4 with a 2. Now this one, if you simplify, it become plus 2, 7 over 8. Okay, now same thing, positive x squared. So the turning point is a graph with a turning point of x minus 3 over 4 equal to 0. So you move this over, it becomes 3 over 4. Then the y coordinate of the turning point is 2, 7 over 8. Okay, in other words, this is a minimum curve, since it's positive. So this is actually the y coordinate of this function is actually the minimum of the y function. Y cannot go below this. So that's it.